Today, wait, what are we doing today? Today we check out some mainboards from Lerdge, just another option you have to control your 3D printer. Hey everyone, Chris here, and yes, we're back with another set of mainboards that you can use on your 3D printer. And this time it's from Lerdge. And the first thing that you need to know about Lerdge boards is they have proprietary firmware. Yes, I know, that's kind of a bummer for some of you. We're not even going to compile Marlin today. But you should be able to configure this whole thing from the screen on the front of your 3D printer. Bed size, auto leveling, the works. And I've never used a Lerdge board before, so this is going to be an interesting experience. I want to get the board set up, get it all cabled to log, and get everything working just by using the tools that Lerdge gives you, just to see how it goes. And we're going to start this whole thing by taking a look at the different options you have if you want to buy a Lerdge board. So here's the boards we're going to be dealing with today. There are a couple of different types of Lerdge board, but here I have the X board, which is kind of a cut down version, and then the K board, which has all the interfaces that you could ever want. So let's talk just a little bit about the X board first. Now this is a fairly capable board. You have a lot of the same things that you would expect at this price point. You've got all your end-stop switches. You have support for 4 stepper motors, 4 drivers. These do come in kits most of the time. We'll talk about that here in a minute. You have some ports that you can use for auto bed leveling, probes, and things like that. Your micro SD, your USB interface, your ribbon cable for your screen interface, filament detection, LED strips if you want to add one, hot end fan that's always on, part fan, PWM controlled, hot end, power management module interfaces, and your Molex connector for your main power source. They do give you the cable for this. Again, we'll talk about that. Now, some things to consider. These are designed for 18 gauge wire, and the maximum you're ever going to be able to push on one of those is around 20 amp. I wouldn't even push them that close. And that depends on the stats that you read and the wire type you use. So just be aware of that. The draw on these isn't going to be as much as something like a screw down terminal. And these boards can't support a heated bed natively. You have to use their power module, so an external MOSFET. And that's what some of these pins are to support over here. You can buy them from Lerdge, but be aware of that if you're looking at something like this. This isn't going to replace even something like ramps or an SKR board. It's not going to be able to do that heated bed natively. And because of that, we're going to focus most of our time on the K board. The K board is basically a ramped up version of the X board. You can support 6 different stepper motors. You have a ton of different end stop pins that you can use for pretty much whatever you want, actually. You've got X, Y, and Z mins. You have E0, E1, EX end stops. You can use these for filament runout, probe and servo pins, USB, micro SD. Both of these boards do run an STM32 processor. They are both F407s. On the X board, the smaller one is a VET6. The K board, this one is a ZGT processor. So quite a bit larger ARM chip on this one. LED support, thermistors of course for bed and hot ends, multiple hot end support, and you can support the bed directly from here. It does have a MOSFET for that. You can still use the power module if you'd like. And this is the dual Molex connector, so you can have like an 11 amp side or a 5 amp side. That's how most of these are set up. Not exactly sure the current rating on this board, but that's usually the split on something like ramps. Remember, those are still designed to work with 18 gauge wire. So more of the same on the larger board basically. You just get more pins to play with and more drivers. Now, as I was saying before, when you buy one of these boards, they come in a kit. And that's because you want to configure them with your touchscreen. That's what makes it so advantageous to get something like this. You don't have to deal with firmware. So in the kit you'll get the board and the drivers, but you'll also get a screen, some heat sinks, your power wires to use that connector, the ribbon cable to hook it up, and a knob. That is not connected. I'm not exactly sure what capacity they use that in, but we'll figure that out as we go. So this is basically everything we're going to use for the install. Screen, ribbon cable, board, the power wires they give us, some heat sinks. We'll get it all set up. I did also additionally buy a couple of these. You can get these from Printed Solid, and you don't need these unless you use Prusa motors. What they call these are Prusa to SKR conversion cables. They get you from this type of JSC connector over to this type that are more commonly used on these types of boards. Again, you don't need these unless you have those clip type connectors, but they are available. I'll leave a link to them. This is going to save me some time because Log does use that type of connector. So here we go, yet another mainboard install on Log. And I'm going to do this one just a bit differently because the last time I did one of these, I got a lot of questions about, did this board swap give you any better print quality? And that's a really hard question to answer because of all the settings. You have the things in Marlin like feed rate, acceleration, jerk values, junction deviation. And then you have all the settings that are in the slicer. Well, this time I'm going to try to compare these two boards. I currently have an SKR 1.3 board here with 2209s. I'm going to use the same type of driver on the new board, but I did do a set of prints on this one, and then we're going to compare those same prints, same filament, on the new board. I don't think that's going to give us a whole lot of valid information because of all those settings involved, but it might be interesting to take a look anyway. So let's start this out. We'll take a look at the prints from Log on the SKR 1.3. So here's the lineup for the SKR board. These are some pretty common prints I do. Of course, we have a benchy. I like to do just a couple of wall print just to see how it's going to turn out. Sometimes artifacts turn up in these when they don't in others. And it's layers a lot, because that's a pretty difficult print in spots, actually. Now remember, Log is not the highest class printer in the world. It is still made of wood, and there's a lot of discount parts on here. So here's our benchy. Not the best benchy I've ever seen in the world. There is just a little bit of inconsistency in the extrusion up here. Our usual deck waterline, like we like to call it. Maybe a bit of under extrusion throughout here. The worst section is probably actually right there. But again, given that Log changes so much, it's not a terrible benchy, not the best one I've ever seen. And then we have our single wall print. I think these do a really good job at showing any type of belt teeth or driver noise. If you kind of work it in the light, you can see any vertical artifacting that there might be. And then we have Sir Layers a lot. He can get just a little bit tricky to get right, honestly. Especially in the shield, when you're moving left and right, sometimes these become really inconsistent, depending on the type of printer you're using. Also, in the sword section, you can see any extrusion problems down in there really well. Again, not a bad print for the machine that we're dealing with here. All of this filament is Printed Solid Jesse PLA Gunmetal Gray. And before we get the install started, these are all 2209 stepper drivers from Trinamic. They're not the same stepper board that I'm using on the 1.3 on Log right now, but I am still using a 2209 chip. So any artifacts that we saw on those prints, we should probably still see them on these prints if they're from the driver chip. And I'll go ahead and put on all my heat sinks. Now be careful when you're putting on all those heat sinks. These big ones actually make me just a bit nervous. They're awful close to the pins on those driver modules, and you don't want to contact any of those or short them out. So make sure they're all nice and straight. And now we can just start moving around the board to get everything wired up. We can go ahead and put on our power connector. Then we go ahead and plug in our heated bed wires, and the badging on this board is great, by the way. Everything is nice and labeled, and your polarity is labeled on the back. So this side is positive, this side is negative. Not every heater is going to need that. Most of them aren't polarized, but if you do, that's how it's hooked up. Then we've got our hot end heater hooked up right there. You can hook up a second heater right here for another hot end. Sometimes on other boards I like to use these for PWM controlled fans. Not sure if we'll need to do that or if we can with this firmware, but that's another thing we can investigate. And we'll just keep moving around the board. Here we have the fan section. We have hot end heatsink fans, 0 and 1. I'm guessing these are always on, because right next to it we have PWM fans for hot end 0 and 1. It would be nice if we could use the one that's dedicated for the second extruder for our hot end fan, so we can control it thermostatically, but I don't know that yet. So we'll just hook it up as it says to. So I've got my hot end fan here, positive and negative, and then right next to it, my part fan, positive and negative. And then next to that, we have our heat bed sensor, our thermistor, and that's where one of these little converters from printed solid is going to come in handy, because I can just use it and convert over to the Prusa style connector. Very handy. Next to that, we have our Hotends 0 thermistor, and I'm not intending to set up any lights or LEDs or anything like that in this video. And then we can hook up our screen. They give you ribbon cables for these. You want the connector side down. Be very careful, these are kind of delicate. Then when you have it seated, just fold down the holder till it snaps in place. You should be good. And then on the board side, same thing. Seat your cable, connector down, should be all set. Now from here we do have our micro SD card slot and our USB slot. We don't have a connector on the screen for any kind of storage, so we will have to read files from one of these ports. And then we get into the end-stop wire section. These are all the 3-pin type, so if you have the end-stop that's on a board, you can power it. All of mine are just the 2-wire type. On this setup, I recommend you use signal and ground. I just have the regular micro switch, so you're going to want these 2 pins for whichever end stops you have. I only have X and Y. My Z end stop is actually a probe. So my Y end stop will go right here, and my X end stop will go right here. And for my probe, these are my probe pins. The positive wire is on the outside, signals on the inside. So on mine, brown wire outside, blue in the center for negative, black for signal. I don't have filament runout on this machine, so I'm not going to hook up any of that. If you do have a BL Touch, your servo pins are right here. So the orange, brown, and red wires will be hooked up right here. And then you can either put your white and black on the probe pins, signal and ground, these 2, or you can configure it with Z minimum end stop. We'll see how that is configured when we get the firmware spun up. Moving on to this corner, this one's labeled M fan. I'm guessing that's if you want to cool the board. It's probably always on. And then we have all of our motor plugs. So we have our X motor. Try to get you a little better shot there. Then our Y motor. We only have one Z motor plug, but I'm guessing you can use one of these other ones for your Z. So for now, until we figure out how the firmware works, let's plug one of our Z motors in the Z motor. And the other one, we'll stick it in E1 since we don't have a second extruder. And then finally, our extruder motor. And everything is a mess, but it is hooked up. Now it might seem I'm trying to fly blind on this. I haven't read the book to figure out how this works, and that is correct. And the main reason for that is this is sold as something that's easy to set up directly from your touchscreen. So I just want to try to plug things in to see if I can make them work through the firmware. That'll be a huge advantage if we can get that done. So we're pretty much ready to power up. We have powered on, the screen is up, the thermistors are reading somewhat close, so that's a good sign. Now we need to go through all the setup, and we should be able to do everything right from here. So we'll head to settings, we'll head to structure. We have a standard XYZ machine, we have an i3 Cartesian, so that's good. And if you click on that, you'll get all the settings that you need to set specific for your machine. Also notice that I'm using this stylus. The touch isn't very responsive on this, plus if I use the touch screen, it's going to get fingerprints on it, and that doesn't look very good in the video. But I found this stylus works a lot better. So let's just look at all these options. Travel space setting. This is where we set the size of the machine. My X is 250. My Y is 210. And my Z is 200. So we're good there. Home position setting. We home at min on X, Y, and Z, no changes. Pause position setting. If you hit pause during the print, these are all the parameters that it's going to use, where it positions everything, and what it does with the filament. I'll leave mine default, but if you need to adjust them, they are here. Change filament settings. If you hit change filament, these are the parameters it's going to follow. I at least want it to get it up to temp. So we'll just say most everything's going to be PLA, let's call it 200. Change filament speed, let's call it 60. That's millimeters a second. Length, on this extruder, I'm safe with 80 to get it all the way out. Extruding length, When it loads it back in, let's call that 80 as well. And retract length, let's go 80 on that. Moving on. Advanced settings. Home offset settings. This is if your nozzle is outside of the bed when you're at 0, 0, 0. Mine is just a little bit in the front. So Y, we're going to set that to -2. So we're good there. All the rest should be 0. We'll back out. In-stop settings. Now I have some questions on this because of the switches that I use. I just use micro switches. And I usually use ground on the in-stop. Ground and signal. That's how I showed you to hook it up. But I want to check some stuff with a meter first just to make sure that my settings are going to be correct. So on the in-stop, I showed you before just like this wire. I had them side by side on negative and signal. That's how I usually set these types of switches up. It didn't like that so much, so I switched to this configuration. I've got one side on signal, one side on positive. I'm not sure why it doesn't work to ground, but it does seem to like this configuration better. So play around with it if you have micro switches, but you might want to consider this config first and set it up like I showed you in the screen. So after doing the checks and looking around, my micro switches, I'm going to set them to normally closed because that's what they read with the meter. So NC. For X and Y, I don't have a Z, I've got a probe on that. And then we'll go to the settings over here. And we trigger low. So I'll set both of those to low. This Z and stop setting should not affect the probe. Now technically I do have it on the high side like I showed you before, but we're waiting for that signal pin to go low basically is what this is saying. And when I set it on the low pin, I don't know if it's floating or whatever it might be doing, but I can't get that to work. So these settings work, we'll go for it. You might have to change yours up depending on what switches you use. Then we'll move on to auto leveling settings. Number of leveling points, let's just set it to 5. Then our probe offset, I'm going to assume these are like Marlin. My X offset, my probe is 23 millimeters to the right. So we'll go positive. And then my Y, I am 9 millimeters behind the nozzle. So we'll go positive. And the Z probe offset, I'm not sure what that is for now. I could go copy it out of Marlin, but we're going to try to set that before we start printing. And the probe is used for the Z minimum in-stop, so we'll check that. And let's check the advanced page while we're looking in here. You have your probe angles. This is for if you're using a BL Touch or something you need to retract, if you're utilizing those servo pins. This is probably going to work for most setups, 10, 90, and 160. How is your probe configured? Mine is normally closed because I'm using a Pinda brand probe. The Pinda ones from Prusa are usually closed. The red light's on when it's not triggered. Some of the inductive ones that you get from AliExpress are normally open. The LED isn't triggered until you trigger. So just keep that in mind. This is where you set it up. And then when the probe is triggered, the probe goes high. Again, depending on your setup, that might be low or high. Mine should work in the high condition. So we should be good for auto leveling. Let's back out. Software retract, we're not going to set that up. I use retraction in the slicer, but it is there if you want to use it. That's also available in Marlin. You can check that out in configuration_adv.h. But we'll take a look inside. I think I want to go ahead and set all these to 0, just to make sure it's not conflicting with my retraction in my slicer. I think you have to run a command to actually trigger this from your G-code, but we'll turn it all off for now. Linear advanced settings, we can take a look in there. I'm not exactly how this is going to work with the G-code. I don't know if they use the M900 command, if that will take effect. On this extruder, it is kind of based on filament and the extruder you're using. I use a 0.08. Now we might have to go back and tune that, but I'm going to assume that I can use the same settings as I do on my other board for now. So we'll take that setting. That's all the advanced settings. Let's check out the other tab. We have second hot-end settings, which we don't have. This is where I would expect if you wanted to tell it you could use your E1 stepper as your Z, but that's not in here. But let's check out EX axis function settings. This is where you can tell it that you want to use that EX stepper for your other Z motor. So before I had it plugged into E1, we'll move it to this EX driver. So let's tell it we want to use it for Z axis. And we do not have a double end stop, but that function is here if you'd like to use it. So at least we know it supports it in some fashion. So that should be all the general settings we need to adjust. So just a quick wiring change on our board. We'll abandon our E1 stepper driver and we'll move it to this EX stepper driver, because that looks like the one they want you to use if you're hooking up configurations like this, at least from the firmware. So we'll test it out. Now let's move on to some other settings from the main screen once again. We'll go into motor. You can set your acceleration. We'll leave it default. You can set speed. Limiting speed is going to be things like feed rate. Mutation speed, I'm guessing they're talking about jerk values here. These are pretty close to stock Marlin values. Homing speed, if it's homing slow, you can adjust them here. Positioning speed. I believe these are the speeds for like home bump. So you hit the end stop once, it comes back a bit, and then does a slow check to make sure it's accurate. So they're going to be a lot slower. So that's what these are. So we'll back up, we'll go to step value. This is where you can set all of your steps per millimeter for the types of motors and drivers you're using. My X is actually 100. So is my Y. And my Z, I'm using TR 8x8s, so I have a setting of 400. My E values, I'm using the Omnia drop extruder. I like to set mine to 408. All the changes we need there. And direction. Direction is just going to be something we have to set on the fly. We'll get to that in a moment after we start moving the machine. Down here, you have your stepper driver timeout. 120 seconds is okay with me. That's when it backs off the current. And then here, we have our trinamic settings. So if you have smart drivers, by default, they're all untrinamic. So anything that isn't a smart driver, like an A4988 or an 8825, leave it here. And this board supports TMC drivers 2208 and 2209. We have 2209s on all of these. So each one, I'm just going to go through and set 2209. We're going to use Stealth Chop, that's the silent mode. 16 times microstepping. Driver current, you have an RSense value. The drive VREF, that's what it would measure at the potentiometer. Running current and holding current. Those are fine for me. 600 and 400, you probably don't have to adjust these unless you're seeing issues like shifted layers. So that's the X driver. I'm going to do the same thing for Y. Z, and the extruder. Now, you'll notice there was a sensorless homing setting that we can use with the 2209. We're going to get it set up and make sure everything's working, then we'll come back and check out that sensorless homing. Then we head into temperature. We'll go into Hotends 0 settings. Now, this is kind of a drawback to this firmware and this configuration. You only have two different types of thermistor, an NTC 100K and a PT 100. Now, not all 100K thermistors are created equal. Like mine, I have an E3D on my hot end. It's going to be close, but not close enough to get perfect prints. So maybe at some point they'll add a few more to this, but just having the standard 100K thermistor like you see in Marlin really isn't enough. But we'll run with it for now. We can keep the mins and the maxes, the protection threshold. You also have PID settings, and you can run a PID auto tune. So we'll come back to this. And heat bed settings, same thing. I do have the regular 100K thermistor on the bed. You do have auto PID tune for this as well. And then preheat settings, you can set these to whatever you'd like. The one-tap preheat settings are actually kind of handy. This is where you can just tap on the icon on the front of the display, the home screen, and you will hit these settings. So most of the time 210 is going to work for me. The bed temperature though, let's lower that down to 60. And then you can adjust PLA and ABS preheats as you wish. Also, you can add user settings. And then we go down to System. System info, you can check out your firmware levels, what board you're running. Calibration, that calibrates the screen if you're having problems. UI reversal, you can flip the screen upside down if you need to for your configuration. And you can also set a password for the screen. Down here you have language. You can turn the sound off, which I'm going to do. And this option right here is kind of interesting. You can upload executable files. I don't know if that's just for firmware updates or if you want to reload a configuration that you've saved, but we're going to check out that save config option here in a moment. You can change the color of your display if you'd like. The green was fine with me, but you have options. And that's pretty much all there is in System. You can also reset everything to default if you wish. And down here is where you can save that config. So let's go ahead and hit that button. And I have a USB drive plugged into my board, so the export succeeded. And now that we have that config file on our USB drive, let's head back into System. And we'll go to that upload feature one more time. We'll hit USB. And we have our config right there in a folder. Let's go into that. And then there's that config file. If we highlight that and hit OK, you can execute an update. Let's just hit update. And that's how you load a saved config. So you can save that config in that other screen and upload it again if you need to, if you make changes or you want to make mass updates like to other boards. So as far as setup goes, we should be ready to start testing. Before we do that, I do want to check and see what the config file actually looks like on that USB drive, just because I'm curious. So if we jump over to the computer and open up that USB drive, we do have this .config file. I'm just going to open it up with Notepad++. And here are all the settings that we just made on the screen. So if you get your configuration tuned in just how you want it, you can save it from that screen, put it on your flash drive, and then you can use that update arrow screen that we saw to reflash it in case you lose it or you get a new board. So that's a pretty cool feature. And before we get started with our testing, there's one more thing I wanted to show you, and that's the jumper caps that are underneath these drivers. The drivers you get in their kit should be set up for standalone. So if you have all your caps on, that'll be 16 times microstepping. You shouldn't have to worry about it. You will have to make some changes if you want to use the other modes, like Sensorless homing and UART. Just be aware, these are pretty much the same as other boards. MS 1, 2, and 3, and probably a set of enable pins. They have documentation for all this. Just be aware, standalone mode looks like that. So here we go. Now we'll start our testing, make sure all the motors are turning in the right direction, make sure the probe's working, make sure it's heating, the fans are working, all that good stuff. You will note that I have a powder-coated sheet on log today. I usually use a Mark 42 bed. That is one downfall in this setup. You're not going to be able to choose specific probe points, but most people probably don't need to do that anyway. Just throwing it out there, be aware of it if you're going to buy one of these boards. So let's just run some testing. Let's go into settings. We'll do movements. Let's see X go right. It's going left, so that's backwards. How about positive Y? It's going negative. That's backwards. How about Z? Let's make sure both Z motors are working correctly. Both motors are working, so that's good. The one that we set in EX is set up correctly, and they are going positive. And just for fun, extruder. Now it turns even if the hot end is cold. Not sure I like that so much. I'm not sure if there is a setting that we can change to make that not happen, but that is a pretty nice safety precaution. It does also appear to be turning in the wrong direction. So I'm 1 for 4. So let's go back into settings. We'll go to motor. We want to go to direction. We need to flip X, Y, and E. We'll back to settings, test again. X seems to be working this time. Y, Z again, why not? And E. So at least we're turning in the right direction now. So let's back out. We'll use our one tap heating. So we'll just tap hot end, 210. The hot end fan did come on, so that's good. And let's tap bed. It sets it to 60, and we're heating up. So we can turn those off for now. And let's go ahead and make sure that we can home and our end stops are working successfully. Let's do home X. We're good there. Home Y. Good on that one. Then we'll home Z. It looks like it's going to move to the middle of the bed to do like a Z safe home, so that's good. It's backed up a bit. It's checked the probe, and then it moves back down. So it looks like the probe is working successfully. I don't know if the offset's going to be correct, but we'll deal with that in a moment. So in general, everything looks okay. Let's go ahead and finish up some of the other settings. I'm going to go back into settings and temperature. Let's go to hot end 0. Let's go to PID. And let's do an auto tune. We'll set temperature. I like to do 210. Tuning cycle 9 is fine. Power limit, we can leave it to 50. Let's go ahead and start. When your PID auto tune completes, it will ask you if you want to save it. Even if you don't hit yes, it's going to anyway. Here are our new settings. So we've tuned to the thermistor that we're using. Now I'm going to go back. I'm going to go to heat bed settings. I'm going to do the same thing. PID settings, PID auto tune. I'm going to tune to 60. 9 cycles is fine. Power limit 50. I'm okay with that. Start auto tune. And our bed PID auto tune is complete. We can go ahead and hit yes. And if you back out, you can see your new values. So now, before I start a test print, I want to check out Sensorless homing on one of these drivers, and we're going to just go for the X driver. Lerdge does have documentation on how to set this up, and it's pretty complete, but there's a few things you need to know if you're going to try to use this on this board. So let's do the settings first. We'll go back into settings, we'll go motor, down here to trinamic, we'll go to X, and down here we have Sensorless homing. By default, sensitivity is set to 0, you're not using it. But you also have some test settings for when you're homing and positioning, or the lower amperage movements that you're going to do, like the double bump. So we can do all of our settings and testing in here, but we don't have to change anything about the driver type, because that is done physically on these drivers. So on the board side, there's a couple of ways you can turn this on. Let's remove this X driver. The easiest way is to just remove all of these jumper caps. Let's just take all 4 off. You want to make sure your board is powered down, by the way. If you look at the driver, there are some solder pads on here. There's more information in the doc on what to solder to turn this into a UART mode or a standalone mode. That's one way of doing it, but the easier way is to just use some jumpers. And you're going to want to solder a couple of pins on these 2 spots in the drivers up here. One of these is for the UART information, the receive transmit. The other one is the diag pin. We're going to use this one up here. By default, they look like this. So we do have to solder those header pins on. They do come with some pins in the kit. And just a quick look at their dock, they do have all those pins labeled so you can tell which one's which. Again, we want diag, number 19, and receive, number 18 down here. So we take all the jumper caps off, we put our driver back on, and we're going to use a couple of jumper wires. These are really long ones, couldn't find any shorter ones. But down here on the board, right in front of that driver, there's a CS RX TX pin. We're going to jump that one. And we're going to put it on the bottom right pin. The ones we just soldered on the top of the driver. Right there. And then the top left pin, that's the diag pin. That's how it's going to get the information from Sensorless homing over to your end stop. So that one will go to your end stop signal pin on X, right there. Now, some of these boards, like SKR boards, they have all this integrated, so you don't have to jump these things to get that information. You just use some caps. That's not the case on this board. They are configured by default for standalone mode, and that just works. You can get stealth chop, but you're not going to be able to use sensorless homing that way. You're going to have a few more jumpers. You can set things like currents in the menu, microstepping, that all works, but not the information from StallGuard. So if you want to use sensorless homing, you're going to have to make these jumper connections. Remember also, that's only available on the 2209, not the 2208. Back to the menu now that we have our caps off and our jumpers installed. Let's go back to Settings, Motor, Trinamic, X. Now what I'm going to do is just move my X axis all the way over to the right, because we're going to run a test. And it's going to continuously move that motor and judge how much effort it takes to move it. And that's going to be the number you're going to use to try to stop it. That's what senses it when StallGuard enacts. So you can use sensorless homing. So back to the screen, in sensorless homing, we're going to do home load test. And it's going to start moving that driver. You see it's set to 0, it's not moving. If you hit start and watch that number, we'll hit stop before it crashes. You can see we hit around 140, 150. That's trying to measure the load that that motor is taking on that driver. So that should give you a rough start for the homing sensitivity. So for homing, I'm just going to start at 140. And then you have a positioning load test. It should be a lot lower. Again, I'll just move my X-axis all the way over to the right and hit start. This is the much slower movement. We've got 40s, 50s. Let's stop it. Let's start with that one at about 45. And then we can back out and we can test our X home. And it triggered prematurely, so it's a little bit too sensitive. Let's go back into Settings, Motor, Trinamic, Sensorless homing, and let's bring our 140 down to 130. And we'll try X home again. Much better that time. So that test will get you in the ballpark, but you're still going to have to play with it just a bit. I ended up with a 130 and a 45. So sensorless homing is there if you'd like to use it. Now I'm ready to go ahead and do a test print. The only thing we really haven't set is our Z offset to get our first layer just right. I'm hoping that we can adjust that on the fly, but I want to go ahead and give it a try. So I'm going to go ahead and preheat hot end and bed. And then let's head to the slicer and get us a file. We'll just start with Tom's bed leveling print. In print settings, you shouldn't have to change anything to use this. It should be the same on this board as most other boards. We'll G28 to home. Just make sure you have your G29 to do your auto level sequence. Also in filament settings, depending on what slicer you're using, you might have G-code in here to set up linear advance. In Prusa Slicer, they use 1.0 on the old firmware and 1.5 on the newer. So they have this long-winded math problem with if statements to make sure you're using one or the other. For this test, since I've already set it on the board via the screen to 0.08, I'm just going to delete that out to make sure it doesn't interject any M900 commands. And that's all. I'm going to go ahead and slice and send it to our USB drive. We're getting up to temp. We're starting to home. It appears that it's going to Z safe home in the center since we have a probe. And now we're going to start our G29 sequence. G29 is done. We should start printing. Now because the Z offset is at 0, I expect the nozzle to be a lot higher. So we need to adjust it down. Just a quick test. It's actually sticking pretty well, but it is still just a bit too high. So on the screen, if we go back into settings, we have up and down here for a layer height. I'm just going to tick down. And I can't really tell where that even made any difference at all. So I'm not sure that you can actually live baby step like you could in Marlin. So let's stop this one. No, we don't want to save the progress. On this board, you can save the progress of the print and come back to it later. But we'll say no. So now we need to come up with a sequence for auto leveling where we can adjust the offset before we get started. So let's preheat the bed and we'll go into auto leveling. And those button presses did actually do something. It's currently set at -0.3. But it really didn't seem to reflect it on the print. So let's do this. Let's run an auto leveling sequence. We'll just tick it right here. It should home and run all of our points. Once that's done, our offset gets reset, so that's good. Let's tell it to go to the center. And now we're at 125, 105, 0. So I'm going to slide some paper underneath the nozzle. You've probably seen me do this a million times. And let's just head down. -0.6 feels pretty good. Let's come up just a hair. Let's call it -3.5. So with that, I'm going to back out. I'm going to head to Settings, Structure, Standard XYZ, Advanced Settings, Auto Leveling Settings, and then Z Offset. We will make that 0.35. And with that change, let's just go ahead and start the print again and see how we do. And our first layer looks much better this time. Much happier with that. So we got that corrected. So I'm going to let this print just for a bit, and then we'll move on to some other prints. While I'm testing, I also went and installed the encoder. I prefer the knobs still to the touch screen, especially if I have to use the stylus anyway. I want to have a knob on there that makes it a little easier to use. These are pretty self-explanatory. You got 3 legs on one side, 2 on the other. They just go on the screen just like this. And then you can solder them on the back. So it might look like a mess, but we've pretty much got the whole thing installed. We got it configured, we got our Z offset set correctly, we're auto bed leveling just fine, and the print is looking pretty good. I also installed that encoder wheel, which I like a lot better than the touchscreen. But there's one more thing I want to tackle before we start the test prints, and that is a firmware update. So the firmware is all available on the Lerdge site, and it should be pretty straightforward. We should be able to just download it, copy a file over to our USB or SD card, and then boot the printer, and it should automatically update. So all the firmware is available over on the Lerdge site. It should be fairly straightforward to do. All we have to do is put it on an SD card or a USB drive, and then we can go into the menu and hit update. So let's go ahead and download the latest. You might want to consider making a configuration backup like we did before, just in case something bad happens, but we should be okay. We've unzipped our firmware. We'll go into the Lerdge K firmware folder. We'll go into the K normal folder, and we're just going to copy this whole K system folder onto our USB drive. Now we'll mount that back on our board. We'll head to Settings. We'll head down to System. Down here at the bottom, we'll go to the Upload arrow. We'll pick our USB, and we'll hit Lerdge K System. We'll head into Firmware, and here's our bin file. We'll select it, and we want to update. Then we'll go to our upload screens. They'll give us a status. This only takes a couple minutes. And if you go back to Settings after that's complete, go to System, System Info, check your version. We're now on 4.2.0. There's a few fixes and things in this firmware, but mostly I just wanted to make sure it was easy to update the firmware. So the firmware was easy enough to update. Now we're ready to start our test prints. Now let's compare our test prints. This is our no infill print. I've been doing a lot of these lately. I think it gives you a pretty good look at any stepper driver noise or layer inconsistency, We like to call it vertical artifacting. On this side we have our SKR print. This side we have our Lerdge print. There's really no noticeable difference. There's inconsistency on both from extrusion. No matter what side you look at, you're still going to see some artifacts. So as far as the controller board causing these types of issues, that's inconclusive. It's probably something in the extrusion or in the 2209. It could even be consistency of filament. And then we have the almighty Benchy. We've got the Lerdge board over here, SK over here. I'm not actually sure what was going on with the SKR. I missed a layer up top and it is a bit stringy. So the Lerdge board Benchy does definitely look better, but I don't think it's the main board's fault. I think it was probably more something I was doing while the print was running. Or I didn't have the temperature quite right. There was some inconsistency on the thermistor that I was running at one time, so maybe I got caught up in some of that. But as far as the main board making one better, again, inconclusive. Any issues you see could be worked out in the slicer. And then we have Sir Layers a lot, pretty much the same thing. There's a few artifacts, one versus the other, that maybe could be caused by the board, but I'd rather think it was something else causing those issues. They're very comparable prints. I did want to point out one thing, and I mentioned thermistor just a second ago. You can see those strings down there at the bottom. That is because I'm using a thermistor that's not directly supported with that Lerdge board. I have an E3D thermistor in there, and the temp table for that and your standard 100K thermistor are different. So I had to compensate for the temperature in my slicer. Running at that 1K thermistor that I was running at made the print way too hot. So I noticed it was doing this, and then I lowered the temp down to 180, and I did that for all the other models. And probably if I had to pick one downfall of this configuration, it was that, the lack of option of temp tables. If they could add a few more of those in there, it would make it even better. So there's a look at the test prints, and as I expected, it's going to be pretty hard to tell if you've switched out a main board based just on print quality, especially if you're using the same type of stepper drivers on both boards. Now if you had a printer that was really dialed in and you knew exactly what to expect out of your print quality, you might have an easier time telling this modification helped or hurt you. But in this configuration, it's not going to matter a whole lot. There's just too many variables to introduce artifacts in this situation. Now as far as the Lerdge board goes, they offer a few modules that they sell as extras for these boards, and some of them could be really handy, but there's one in particular that I might recommend to you that you grab. And that is the USB module. You've got USB-B over here, but then you have a spot where you can mount a Wi-Fi card, like an 8266. It just mounts on top of the board with a couple of pins. I'll show you how it mounts up on the X board because it's exactly the same for the X and the K. But it just goes right here over your micro SD card, just like that. And if we head to the computer, and after your module's on and you're cabled up USB, you can just hit connect, just leave both of these on auto, and the board connects right up. You can head to terminal, it spits out a lot of information, and you can interact with it from here with whatever G codes that these boards accept. Those are on the Lerdge website. And speaking of their website, Lerdge does have a control software out here if you'd like to download it and check it out. If printing tethered is something you like to do, maybe you might be interested in it. So there it is, the Lerdge mainboard testing and install is now complete. And I have to admit, going into this whole thing, I was a bit of a skeptic, because I like to mess around with the firmware on these machines, especially Marlin. I like to get in, check out the features, change them up, recompile and upload, just to see what it's going to do. But I realize not everyone wants to do that. And this board is as advertised. You can configure your 3D printer directly from the touchscreen, no problem. And there's a lot of features on that touchscreen available that I thought wouldn't be there, like adding a second Z motor, sensorless homing, and linear advance. So that's good to see. Now there are downsides, like this board setup from AliExpress with all 6 of the drivers costs around $110 to $120 US. So keep that in mind. Also, it is proprietary firmware, but they do seem to update it regularly, so you can check out the site to make sure you're not missing anything. Now, at the end of the day, would I buy one of these for my 3D printer? Me personally, no. I'm going to stick with the more cost-effective lower-end boards that run Marlin, just because that's what I like to do. But if you need a one-stop shop that's easy to configure, you don't have to mess around with flashing anything, you might want to check these out. Just be aware of the features that are offered on the different board sets and the modules that you can add. Well, that's it for today, and I will see you very soon on the next one.